Thank you for coming to my session on raising your minimum expectations for software delivery using DevOps. Um, a little bit about me. There we go. Haha, it worked. A little bit about me. I lead technology and engineering teams at HEADSPRING. We're a software consultancy in Texas, and we work in a variety of industries. I have more than 18-ish years of experience developing software, managing teams, connecting people, doing a lot of different things over those years. and some of my expertise areas, architecture, DevOps, processes, I like to think that I know a little bit about a lot of things. And it's always fun to solve new problems that way. And despite what the picture of me looks like, I am really bad at ping pong, but it's still fun to say and it's fun to play. Um, I have my bachelor's degree in computer science and also my master's in business administration from the University of Houston, and have found it interesting to combine the technology with the business, and it's really helped a lot in my career over the years and helps me really see a perspective of technical and business at the same time, which I think helps with the DevOps aspect because DevOps tends to be a combination of business and technology and how the two work with each other. So, why? Why are we talking about this? From the title of the talk, it's a little wordy. There's a lot of words, but we want bits and pieces. So, raising your minimum expectations. So, in the States, we have these commercials for makeup from L'Oreal, and the tagline is because you're worth it. And it is really about you. It's about your time that you spend when your day. It's the limited thing that you have each day. So, when you're improving your ability to work more effectively, then you have more time to spend on things that are more interesting, and you don't have to spend them on things that are not. So think about yourself, right? DevOps and improving your expectations. It's about yourself. How can you do? How can you use your time more effectively? For software delivery, now software is not just writing code, because as soon as you write the code, it doesn't mean that it magically ends up in the customer's hands and they're using it. It's about a software delivery process. So software delivery is starting from writing the code, or even before that, the idea of the code. What is it that you're trying to accomplish with your customers? And how do you take that into a software product? How do you validate it and test it with your customer and then deploy it so that the rest of your customers can now use it? And that whole process is software delivery. So when we talk about software development, it really isn't just code, it's so much more. And so when you think about your process, you need to think about the entirety of the process. Because, like the quote says, shipping is a feature. Your software really has to have it. If your software doesn't ship, your software doesn't exist. If your software doesn't appear in front of the customer, it can't create value for the customer. And so when you think about software, think about what is my process of getting the software to the client, getting the feedback from them. Did it work? The worst thing for a software developer is to know that we spent 6 months building a product, putting it in front of the client, and they're like, oh, that's nice, and they never use it. And then we come back and we ask our business, so what happened? Is it great? Did they love it? No, they're gonna try it out next quarter. That's not not very fun, but we have to think about that. So software delivery is the whole process. And finally, using DevOps. Now, DevOps is one of those terms that's used in a lot of ways, a lot of places. And so you may say there's a DevOps team, or there's a DevOps person, or a DevOps department. These are all incorrect. DevOps is a process. DevOps is a culture. DevOps is a very common pattern that you see here. That's build, measure, and learn. So you build some code, you build some software, you deliver it to the client. You measure, is it getting the result that we want? Are they using it? Are we seeing the benefits of it? And then learning from that and applying it back into the process. So as you think about your software or your technology or what you're working on, think about the build, measure, learn cycle, and how do you incorporate the feedback loop there? Because with modern technology, you want to be able to, it's complicated. Everyone knows that technology gets complicated. Talking gets complicated too. And you're trying to learn from that because you're going to try something and say, well, did that work? I don't know. If you don't learn from what you've built, then you're going to build the wrong thing next. And again, it comes back to wasted time because your time is worth it, right? Because you're worth it. And so we have to be considerate of the whole process. So as you think about software, think about, how do I build an iteration or a part, an increment? How do I measure the success of that? How do I learn from that so that I can feed back into what I'm building and build it more correctly? Okay, so as we talk about raising your expectations, we want to think about what are some principles that guide these thoughts, because we can come up with a lot of different things. However, and we did come up with a lot of different things, but we want to think about the key principles that guide this, because I'm going to make a list of whatever I can list in 25 minutes, but there's going to be other things that you are going to be looking at. There's other things that you're going to find and you're going to think about, and you have to put it into context. And I think when you look at these core principles, then it helps you to frame or to think about these ideas. So for example, let's talk about one. This is actually borrowed from UX, from user experience. And it's the principle of least surprise, and sometimes called the principle of least astonishment. Because sometimes you want to be surprised, but you don't want to be astonished. And it's a bit of a terminology thing, but I guess astonishment would be where I want to use something in a way I expect it to be used. So for example, I see this very common occurrence, right? The thing that we see all the day, every day we see one of these. And as people in North America, because other Europeans see it differently, other countries see it differently, but in North America, the plugs look very similar to this. So I have a electrical plug. I know which end goes into this. I know what not to do with this. And it works pretty much as I expect it to. But if you take something like this and say, all right, now put your key in there, people are not going to do it, because that would be a surprising or astonishing thing to do. That doesn't make any sense. Why would I do it that way? So we have to be considerate of what we present to our developers, and trying to think of how do we position things in a way that's the least surprising, the least astonishing, the most expected way to do things, because that means that when they think about it, they don't have to think too far out of the norm, right? They say, okay, well, if you put this component here and this component here, I expect these two to fit together. Or if I have a JavaScript application and I clone the repository from GitHub and there's a package JSON, well, then I know that the next thing I'm going to do is I'm going to npm install or yarn install, or I'm going to install all the packages that need to come down, and then I can look and see what my tasks are that I can run against that code. So this is a developer habit that's been formed. And if you do something different from that, then people are not going to be as comfortable using your project or consuming your software. This applies not just to software, but also to a lot of other things. But in software, there is definitely a developer experience or a user experience that you have to consider, because someone has to read the code that you write. That code isn't just created once and it never is touched again. It has to be maintained. It has to be used. So consider this when you're thinking about the whole experience. And as we talk about the different guidances for raising your expectations, this is one of those really key guiding principles. Failing fast. Too many times we think about failure as being bad. But the thing is, failure is natural. Failure happens. You can't succeed 100% of the time. I would be very, very wary. Just like anyone that's doing software development, if your code works on the first try, be very suspicious. Extremely suspicious, because something like that means that you may have missed something, right? I don't expect my code to work on the first try. I've been working for software for 18 plus years. And if my code works on the first try, I'm going to double, triple check everything just to make sure that I didn't miss something. But these are some great quotes. So fail fast, fail hard, fail often. The quicker you fail, the quicker you learn, because failure means feedback. Failure means that something the system told you was, that's not correct, and we need to do something different. And so the sooner you fail, the sooner you can correct. If you think back to the build, measure, learn cycle, the sooner you can get that measurement that says, oh, exception, or oh, there's an error, or oh, the user looked at this and said, no, that's not correct, then you can learn from it and contribute that back into your building process, and you can continue more quickly. And you're not taking as much time building something that's wrong, where you don't know that it failed until further down the line. And then, of course, there's always the famous quote from Thomas Edison about the light bulbs. It's like, I haven't failed. I've just found 10,000 ways that it doesn't work. And this is the same thing with software. You keep trying, and you'll find a bunch of ways where things don't work. But you have to remember to learn from those and keep in mind those lessons learned as you continue. So failing fast. Failure is normal. Failure is an option. Failure is okay. So when you think about your software, you think about your development practice, remember that failure is a normal part of the process. It is a healthy part of the process that you have to embrace and use to be more effective. And so if anyone's been in software for a while, you've heard the 4 letters in English. It's RTFM, which is read the fantastic manual. And because if I tell you to go read the manual, I assume that there's a manual. First of all, I assume there is a manual. I assume it's well written enough that you're going to actually understand it, because otherwise you're going to go read a manual that's terrible, and you're going to come back to me and say, that was terrible, that was a waste of my time, because I'm worth it. But that means that someone has to write it too. So thinking about documentation, thinking about how do you direct someone about your software. And software developers have to be writers. We have to describe in plain language what it is we're building, because software is complicated. There's a lot of things going on. So think about how you write the manual so that someone else can read it. And hopefully they don't bother you. Or they'll come to you and say, like, that was great. I really appreciated that. And finally, know your dependencies. Software, this term has come up more recently, called a software supply chain. And today in the world, we're having a lot of supply chain issues, and software is actually one of those common supply chain issues as well. It's not that things aren't shipping, but it's the quality of the items. Are there vulnerabilities? Is there security concerns? Are there other things happening with this? Our software that we create today, complex software, all depends on a huge number of libraries, a huge number of dependencies, some from the vendor. Like, for example, we use .NET a lot in our work. And the Microsoft open source libraries, the base class libraries, all of the little third-party components that we use to build software more easily. So our code is maybe 5% of the product we build, and there's 95% is all of the other libraries and tools, not to mention your operating system and everything else underneath it, just to make your software run. So knowing those dependencies, knowing that there is this ecosystem, helps you understand better how complicated the software is, how well you should be documenting it, and what awareness you need to have of the systems. So with those key principles, now we can go into minimum expectations. And I say minimum expectations because it doesn't mean you're always going to see this, but you should expect this of other people, but also of yourself. So this means that you want to apply this to your own software and your own technology, but also help other people do it too, because you'll be consuming their product, they'll be consuming yours. And so if everyone has the same minimum expectations, then we can save time because you're worth it. This famous file, readme.md. If anyone's been around GitHub and open source, most repositories have the infamous README file. And your open source, your source control tools, your GitHub, Azure repos, Bitbucket, GitLab, whatever you're using, this is the convention, is that you have a readme.md file. And this file should tell you, how do you start? What is this project about? How do I use this project? How do I pull the code? How do I compile it? How do I consume it? If you don't have anything useful in this, then people are going to ask questions. There's going to be issues on your issue tracker. Hey, how do I build this? How do I do this? So you want to capture your most common questions and put it in there. What's really neat about the README is that it renders into very rich HTML. So a very simple language of Markdown lets you create a very, not a great polished one, but it's a good enough documentation. Excuse me, that gives you the formatting. It gives you a really simple setup. You can do tables, which are terrible, but it'll work. But normally it's the code samples that you pull in, then the little bits and pieces about your application, and you're creating a simple document that describes it. And so when they go to the web page, and even if you go on the phone and you access GitHub through the phone, you can see this rich rendered documentation about your project. And so think about that experience that you get when you first go into an open source library or go into another project and you see that nice documentation. Here's what we're about. Here's some badges. Here's our sponsors. And then clone the repository. Here's what you do next. With that, you want to think about documentation on the API as well. So you can document your code, how to build it, but then also you want to document how you run it. And OpenAPI and Swagger, it's the same word. This term, the exchange, like, so version 1 and 2 were called Swagger. Then version 3 said, you know what, I don't want to say Swagger, so we'll call it OpenAPI. And it has a declarative way to describe an API. So if you're building a service that has web requests and HTTP requests, then there's a way for you to describe that API that will then generate an HTML page that people can use for experimenting with it. You can also take that same link. So in the screenshot over here, you'll see there's a little bit of link that says to a JSON file. You can take that JSON file and you can import it into Postman. And Postman is a tool for running web requests and playing with APIs. And you can import it and it will create the whole structure for you of all the different requests that are in your API specification. You can take that same specification and you can generate a client library for it. So within Visual Studio, you can import an OpenAPI specification and it will generate a code for you that matches it. It'll create all of your class objects. It'll create the APIs that you need. It'll make a bunch of async related HTTP calls, and it does that work for you. So just because you see an API you have to consume doesn't mean you have to sit there and type all the individual commands. The specification lets you create it by automatically create it. Like I said, we do .NET code a lot, and there's a library called Swashbuckle that will take your API structure and it will interpret it and generate this stuff for you. It'll generate the specification for you and it'll generate the file for you. So you don't have to do as much work. Think about the time it takes for a developer to get from cloning your repository to running your code, and make sure that that time gets better and better, because the longer that takes, the more likely they are to contact you or submit an issue or drop your project altogether and say, you know what, it's not worth it. We'll go do something else. Because time is important. Time becomes the most important thing. So improving your efficiency, improving your time is going to help everybody feel better about interacting with your code and you interacting with other people's code. Integration testing. When you run your code and you test your code, you want to be able to minimize the number of extra tests you write. One of the biggest complaints that I hear about people that are critics about unit testing, they say, well, it's throwaway code, right? You're not really testing the real code. You're testing the small little piece. Well, I say, well, that's why we really want to push you to do integration testing instead. So why test a subset of the code when you can test the real code against a real database? And so when you're at runtime, you're testing again, you're hitting the real database and external services. And when you're running locally for integration testing or on your build server, hit a database container, a test database, something else that you set up a test harness for your application that can talk to a test database, run the exact code that's going to run, because that way you're testing the real code that runs in the real area. There's some benefit to doing unit testing, but integration testing ultimately becomes more useful, and it becomes documentation for the users of the code, because they'll see, okay, here's a scenario I'm describing in my test. Here's exactly how we set it up and call it. And so now you've got examples that are set up in your code that describe how to run the tests, how to run the application. containerizing databases. So there's a lot of third-party databases. So think about Mongo, Postgres, SQL Server, MySQL, other databases that you work with, even cloud ones, DynamoDB, Cosmos DB. Um, Name your database. There's a lot out there. When you're working locally, you want your developer to be able to run testing. You don't want them to have to create an account in the cloud to run the integration tests or the unit tests if you can avoid it. So if you say you clone a repository and then here is a Docker composition file that spins up a database or spins up my cache, my database, all the things that I need to work, and they don't have to install anything extra. If they already have Docker installed and working, which most people do now, or some container system, then they can run, for example, in the code here, they can spin up a Postgres database for version 12. Here's the default extremely secure password. Don't tell anybody. Here's the port number I want you to use, and let's mount the data so that we can keep it between runs. So something like this would allow a developer to spin up the database that you want very quickly and run the unit tests, and everything's great, tear it all down, and suddenly there's no leftovers on their system. They didn't have to install the database server. They didn't have to install something strange or configure it or set up another special port or something else. Temporarily creates a database, run what you want to run, tear it down. This is this kind of cycling pattern that you want to take where you say, okay, let's try this. It works, great, clean it up, let's continue. And now we have at least astonishment, because what I expected was if I'm just going to try out your code, I don't have to install 12 things to make it work. I just want to use your code. So this is one way you can do that. Local stack. If you're using AWS, there's a really neat library called Local Stack. Really neat library called Local Stack that will let you do testing of AWS resources locally. So there's a lot of things that you can run tests for, you can deploy into it, and lets you test out those things that you may not be able to get to. Experimenting in the cloud. So if you're working in the cloud and you're doing, so Local Stack was an example of it. If you're experimenting in the cloud, then you need to take advantage of the cloud. So I have deployments into my development environment and my test environment. Then I also want to be able to build experiments. I want to try out something different. I want to see, because I want to test something. I don't know if it's going to work. It's probably not going to work. It may fail, and I'll learn from that. But I should be able to build new environments as I want, spin them up, try them out, tear them down when I don't want them anymore. The technology is there today. In Azure, AWS, Google Cloud, even locally on some infrastructure as code solution or infrastructure as a service solutions internally, you can spin up temporary environments very quickly. Versioning, traceability. So think about the version of the code. So if I build the code and it says it's version 122, and then I deploy the code, it says it's version 122, and I run the code and the code tells me it's version 122. Now I know the code exactly that's running. So if I see a problem, I can go back and see where it is. So if you want people to be able to see, like, well, what code's actually running in the cloud? What code's running in the dev environment versus test? That's going to be available. Structured logging. This is a kind of a weird one. But if you want to be able to see what your application is doing, structured logging gives you JSON-based logging, where you're logging JSON to your system, and you can feed that into a lot of downstream things like this. This is SEQ, it lets you look at logs, things like Datadog and Elasticsearch as well, learning from your system. And so as you learn, these lessons need to go into your README. As you learn what happens to your application, it goes into your documentation, and you say, here's how it should work. This is what you should see. And that's how you close the loop now on the DevOps, right? You build something, you're measuring how it's working, you're learning, you're teaching the next person so that they can work too. Because time is important. And so that you're saving other people's time, and because you're worth it. Thank you very much for listening. I'm hoping that this helped you raise your minimum expectations about what software engineering could be, what software development could be, and opens a lot of questions up, so you can go and reach out.